Proportion applications. Before solving a proportion, we can write out the fractions that are being compared. Each denominator has the same unit of measurement, and each numerator or top number will represent the same unit of measurement. So let's go over a few other things first. Here we have a hydraulic system where we have two pistons. We have a smaller piston on the left and our larger piston on the right. Now, what's the most important mathematical relationship to understand here is that the pressure is equal to the pressure on both sides. This is important because pressure is equal to force divided by the area. So we have our force here and we have our area. So we can see that on the left, it's going to be a much smaller area. And then our area on the right is going to be a lot larger. What's important to understand is that this force input and this area will give us a certain pressure, which is then equal to our larger piston, which will have that force with a certain area. Now, what's important to understand is the input force and then the output force are going to be significantly different. And this is because of the area of the larger piston. Because the pressures have to be the same and it has a larger area, that means that force is going to be also greater in order to keep the pressures to be the same. So this is why this is important, because you can put smaller input force and get a greater output force. So that means our force over area of the smaller piston has to equal the force divided by the area of the larger piston. So this is the mathematical relationship that we are going to continue to understand. So let's look at example 1. Example 1. The input piston force is 50 pounds. And the area of the small piston is 1 square inches. What is the output piston force if the area of the larger piston is 4 square inches? So for this problem, we're going to have to set it up. So we're going to write out our fractions. So we have 50 pounds over 1 square inch. And then we also have an output force, which we don't know. So we're going to leave it as x over 4. So here's our two fractions that we're comparing. And then we're going to put an equal sign because it's a proportion. And then what we do, like we've done before, is we're going to cross multiply. So we would take the 50 times 4, and then that would equal to 1x. So 50 times 4, we'll get our calculators. So 50 times 4, which is equal to 200. So we get 200 pounds as its force is equal to our output force. So let's look at another example. Example 2. The input piston force is 500 pounds. And the area of the small piston is 1.5 square inches. What is the output piston force if the area of the larger piston is 5 square inches? So for this, we're going to set up our fractions. So we have 500 pounds over 1.5 square inches. So it's force over area. And then we don't know what the force of the second piston is for our output. So that will just leave us x. And then we know it's 5 square inches for the area. And then these are equal to each other as it's a proportion that we are dealing with. And then We're going to cross multiply. So we get 500 times 5, which is equal to 1.5x. So let's get our calculators out and do this multiplication on the left. So we get 500 times 5, which is equal to 2,500, which is equal to 1.5x. Then we need to divide by 1.5 to get x by itself. And we do this on both sides. This just becomes 1. So let's go ahead and divide this by 1.5, and we get 1,666.67. So let's go ahead and round to our nearest whole number. So it's 1,667, and this is in pounds. So let's go back to visualize this for real quick. So we had 500 pounds of force put in. And then our result, which is a greater force, as you can see by the arrow to indicate this, was 1,667 pounds. So as you can see how this kind of relationship works, so that way you can kind of see when you get an answer to see if it makes logical sense. As we understand that the smaller piston, we put an input force, and then we get a larger output force because of the area is so much larger, and the pressures have to be equal to one another.